In this previous example, we had the frequency distribution with all the classes, aka bins, aka groups, all pre-made for us. But the question arises then, how would we build these for ourselves? How would we take data and figure out where we're going to start and what our class width is going to be to build a table like this? And that is actually started on the next page. However, this little box should actually be at the start of the next page, and I'll fix that so it is for future. So I'm sorry about that. You can see I've already got it there. So for your lower class limit of the first class, which is where you begin, right? So this is where to start the table. You generally choose either the lowest observation in your data set, which is called the minimum, or a convenient number that's slightly lower than the smallest observation. That's usually with some rounding. So for example, if your lowest data point is 2.34, you might just round it 2 because it's easy. Now that said, if it's really low number for your minimum, and if it's ratio data, it's often nice to choose 0 as your first class's lower class limit. So that's pretty frequently common that we will do that. Now the class width is a little bit of a formula. So what you do is you decide how many classes you want. You generally want between 5 and 20. There are exceptions to that, but for the most part, if you're less than 5 classes, you're too few. And if you're more than 20 classes, it's too many and too confusing. So you want the Goldilocks sweet spot of being between those two values. The smaller the data set, obviously, the fewer classes you're going to have because there's just not as many data points to put in there. And then the class width formula is right here. So you take your largest data value minus your smallest data value, and you divide it by how many classes you want. So in our case, for example, the max is right here, right? And the min is right here. So that's the maximum, that's the minimum. And speaking of which, the smallest observation in the data set, that's another way of saying the minimum. Then you round up. No matter what, it goes up to the nearest convenient number, usually an integer, but multiples of 5, 10, 100, it depends on what kind of data you're working with are nice. So say if it came out to 87, you might round it to 100, for example. Or if it came out to 8.7, you might round it to 10, just to make it nice. And because of rounding, you might have fewer classes. So when you do that rounding, let's say 87 to 100, you were shooting for 20 classes, but because you rounded it, you might end up with 19. That's totally okay. Don't worry about it. So the desired number of classes might not be exactly the number of classes you end up, but that's what you're shooting for. All right, so let's do this in an example, and that will hopefully clarify things. The following table shows the number of at-bats for each batting member of the 2013 to 2014 Jackson College men's baseball team. Yes, this is real data. I got it off of JC's website. So at-bats, by the way, if you're not familiar with baseball, are plate appearances, not including bases on balls, being hit by a pitch, sacrifices, interference, or obstruction. So you go up to the plate, and you're not given a base on ball or hit by the pitch. That would be not good. Sacrifices and so on. All right, so I have these data, by the way, if you're interested, at that particular StatCrunch file. So you're more than welcome to look this up if you want to. All right, so we're going to construct a frequency distribution with 10 classes using 0 as the lower class limit of the first class. Okay, so I already took out part of it because I tell you right there, I want you to start at 0. Boom. I know that I'm going to start at 0 because it told me to. If it didn't tell me to, I would have probably started at 2 because 2 is the lowest value in the data set. All right, now I'm going to have to find the class width in order to figure everything out. Now the width, according to the formula above, the width is the max minus the min divided by, in my case, 10, the number of classes that I want. So that would be 148 because I put these data in order. So 148 is my maximum, 2 is my minimum. I divide it by 10. So that's 146 divided by 10. Oh, make sure that when you do this, let's make a little note. You have to do the subtraction first. It has to do with order of operations. The reason you're subtracting, dyslexia, sorry, first, not first, first is because the division sign in the middle is a grouping symbol. So if you remember, please excuse my dear Aunt Sally, right? Parentheses, this counts as parentheses. It groups together that subtraction. And if that's going to be confusing for you, then it doesn't hurt in the formula itself, say if you're writing it on your formula sheet, to put a little parentheses around it and say, I have to do largest max minus min, largest minus smallest. Do that first because that division sign groups those together in a parentheses, and then I divide. Right? Parentheses come before division. So I take 146 and divide it by 10, which is 14.6. Now, this is where the rounding comes in. I would like to round that up to a nice number. 14.6 I don't want to deal with. So I will round up. So even this was 14.2, I would round it up. I would go to a higher number, not a lower number. So if I go lower, I might end up with 11 classes. So I'd rather have 10 or fewer. So I'm going to go to 15, right? 15 is a perfectly nice number. Okay, now how does that help me? Well, because then if I take my class width of 15, I'm going to add it onto my lower class limits. So this was 0, 0 plus 15, 15 plus 15, and so on, and so on, and so on. There are all my lower class limits. And I find those by adding the class width. Adding the class width to get all those new numbers. So I start at 0 because it told me so, and then I add 15, add 15, add 15, and so on. Now, what about the upper class limits? Because this is basically the skeletal structure of what I want. Now I just need to figure out the upper class limits. So I have all the lower class limits. Well, okay, so I want the number that is below 15. So that would be 14. Now you could say 14.9, but decimal at bats are not possible, so there's no point in doing that. This is an example of discrete data, but because there's a wide range in the values, we're going to treat them like they're continuous and put them into groups. So technically these data are discrete. I guess I can make a note. There's a wide range from 2 to 148, so we bin them, which means we're going to treat them like they're continuous. And the way I mean that is that we're going to have bins or groups, classes in the table. Because discrete data don't necessarily have to have bins or classes, but you wouldn't want to go from 2 all the way up to 148. That would be silly. So we're grouping them into groups, right? That's what I meant on the previous page when I said this is for continuous data, but also for sort of discrete data that has a lot of values. This is what I mean. There's a lot of range here, so we're going to put them into groups. All right, now what about the next number? So if this was 14, and I didn't go to 14.9, again, because these are discrete data, so I'm not going to bother with that. What would be the next number? Well, this next class, 15 to something or other, ends just shy of 30, right? Because the next class is going to begin at 30. So I want to take 1 away from 30 and make this 29. Now there's another way you could figure that out. 14 to 29 is 15, right? So if you have a consistent class width, which we are assuming that we do, if you have a consistent class width, then you can just add on 15 all the way down and get all your next numbers. It's also the equivalent of 1 minus this next number. So if this next number is 45, then this is 44, which by the way is what 29 plus 15 is. This one's 59, because that's 1 shy of 60, 74, 89, 104, 119, 134. Now here's where it's tricky. We have a consistent class width of 15, or at the very least it's 15 down here, close to the end. So that means that for this last number, you're going to add that 15 and end up with 149. Because there's no next number to figure out, right? This next number would have been 150 if you keep adding 15. So it's the number right before 150. That's another way to think about it. And again, if your class width is consistent through the whole table, then that's great. And it makes it so that it's easy and you can figure out these values. So let's just make a note of that. So consistent class width means it's the same all the way through. It was 15, 15, 15, 15, 15 all the way down, unless otherwise told. There are times, and again, age is the one that tops to the top of my head, that we like the first classes to be like 5. So they'll be like, 15 to 20, 20 to 25, and so on. And then they get to the end and they're like, 60 to 75, right? So they put people of a certain age in groups together. And there are good reasons for why that would be. It's just not something that we're going to see right now in this particular example. And by unless otherwise determined, I mean unless otherwise told, I guess, or given, right? So unless you're told otherwise, you just assume that you're going to have a consistent class width. And that's the way most classes work. There are just some special circumstances where we don't want that. Now, what about the frequencies? Well, you count, right? I'd love to tell you it's more glamorous than that, but you just count and figure out, hey, how many are between 0 and 14? Right there, there's 5 of them. How many are between 15 to 29? Well, you count 15, 15 counts in there. So 1, 2, 3, 4, and so on. There's 1 from 30 to 44. 45 to 59 is 2. 60 to 74 is 2. Then 3, 2, 2, 1, and 2 in that last group. And notice that high number right there covers my maximum. My maximum value has to fall in that class, and it does. So we can make a little note. If it doesn't, you've done something wrong. But all in all, that's how to make a table for yourself. We won't do too much of this, but it's nice to know how to do it. So you start at a low value or a convenient value, minimum either your minimum or a value that's close to it, that's a little bit lower than it, or 0. And then you find your class width, you round up to a nice number that's easy to work with, and then you assume a consistent class width and build your table on both sides using that class width. And make sure that your max is covered in that highest class.